Hello friends, welcome back to my YouTube channel Physics Club by Shakti sir. So in today's lecture I am going to add on the part 2 based on numericals on impulse momentum theorem. In part A, I have discussed few numericals, maybe 6 or 7 numericals which are basic and few are very conceptual, but here again I am bringing the part 2 of the episode. So let's start with the impulse momentum theorem numericals, and if you are new to my channel, please subscribe my channel. Let's start. So the first numerical is based on some hydrodynamics, the concept of hydrodynamics. So here it says that if we have a tube something like this, a U tube, we can draw it like semicircle. It has a cross-sectional area A everywhere. So let's make it A. Cross-sectional area A. So this is a semicircle, sort of semicircle, and the diameter is D. And here is a marble which is moving with velocity V and have mass M. So the semicircles from this point starts at A and ends at B. So the marble move in this direction here. So we need to calculate, we need to find out what force does the marble apply on this U-shaped tube. So this is the question. So find the force applied by this marble when it is moving in this tube. How much force it will exert on this tube. So let's discuss this numerical. So this is the scenario. So this numerical is based on impulse momentum theorem. You can see here the momentum of the marble is in this direction, mass into velocity, and when it's coming out of the tube, the momentum is mass into velocity towards right side. So we know the change in momentum is nothing but the final momentum minus initial momentum of the marble. The final momentum of the marble is equal to mass into velocity, and the initial momentum is here, mass into the velocity is towards left side, so I am taking this minus sign. So the magnitude of change in momentum, here we can write it's 2 times of mv. It's the magnitude of change in momentum. Okay, so from the impulse momentum theorem we can conclude, or we know that the average force can be written as the change in momentum divided by this, right? So we know the magnitude of change in momentum. Now we will calculate the time taken by this marble from A to B. As I have discussed, this is the semicircle, so and it is moving with velocity v. So delta t is nothing but this distance. As we know, if it is a complete circle, the circumference of the circle is equal to 2 pi r, but for semicircle it is equal to simply pi r. So pi and r equals to diameter divided by 2. So this is the distance and it is divided by speed. So this is the time taken by the marble from A to B. Now the average force is nothing but the change in momentum, which is equal to 2 times of mv divided by time taken, pi d by 2 v. Let's solve this further. It becomes 4 m v square divided by pi d. So this is the average force which act on the tube due to the marble when it's passing from A to B. So this is our result, this is our answer of the situation. Okay, so this is the first numerical. Let's move towards the second numerical, how we can solve the second numerical. What it says, the second numerical is there are n number of, so this is surface, and there are n number of marbles hitting on the surface n number. n number of marbles hitting on the surface elastically. Alright, so the collision is elastic. We need to calculate elastically each second. So in every second, so n number of marbles are colliding with the horizontal surface elastically. We need to calculate how much force is acting on the surface, or how much force the surface is applying on the marbles. Is nothing but just the application of impulse momentum theorem. So let's discuss the situation of one marble. As one marble is moving downward with speed, let's say u, and it has mass m. After collision, it moves upward with linear momentum mu, but in the upward direction. So this is the situation of after collision, this is the situation of before collision. So the initial momentum is negative mu, and the final momentum from here is mu. Upward direction is taken as positive, and the downward direction I am considering the negative sign due to the downward direction. Alright, so the change in momentum of the single marble each second is nothing but mu final minus initial, and it comes to be 2 times of mu delta p. What about force? So average force is delta p, and the time taken, is each second. It means 1 second. So 2 mu divided by 1 equals to 2 mu. So this is the average force exerted by the horizontal surface on the marble each second in one collision. So this is 2 mu, and if there are n number of marbles colliding with the horizontal surface each second, then the total force is nothing but n times of 2 mu. So this is the answer of this situation, n times of 2 mu. Okay, so these are the two numericals. Let's move toward the third numerical. What it says. So again we have the situation, marble is hitting with the vertical wall elastically, and we are given a graph of the variation of force with time. So how we can solve that situation, we will discuss in the numerical third. But keep in mind that if you want to score very good in physics, be continue on your chapter, on your content, and just follow one book. If you are following multiple books to solve the numerical problems, and you are switching from one book to another book and making one favorite, and after 1 week making the other book your favorite one, then you are just wasting your time. So my advice to you is that just follow one book. And if you are in India, you know which book is best. Obviously, if you are preparing for JEE mains or NEET exam, just follow the H.C. Verma. If you are, but H.C. Verma you can follow if you have a good teacher who has given you the very well theory, so that you can solve the numericals. Otherwise, for self-study, you can follow the D.C. Pandey. So D.C. Pandey is self-sufficient book. With you can study with the help of D.C. Pandey. Series of books. There are series of books written by D.C. Pandey. So let's move to the numerical number third. So we have a third situation, something like this. So we have a wall, and a marble is moving with speed u, having mass m. Again, it is colliding with the wall elastically. Okay, it's colliding with the wall elastically. As it is colliding with the wall elastically, it will come back after the collision with the same magnitude. So P initial can be written as mu, and P final can be written as minus mu, right? So it will come back. So the change in momentum, I am writing the magnitude is nothing but 2 times of mu. this is the episode we know how to handle the change in momentum in such situations under the elastic collision. But it is given in the numerical that during the interaction of the marble with the wall, the force of interaction between the marble and the wall is variable, and the graph is here. So this is the graph. It is time t and it is half of t, 0.5 t, and this is the maximum force F naught. Variation between force and time. So the question asks find the value of F naught. What it says? Find F naught. Okay. So the situation is clear. A marble is hitting the wall elastically having mass m and speed u. We need to calculate the value of F naught. How we can solve this situation? Again, with the help of impulse momentum theorem, we are very easy to solve this situation. So here we know the change in momentum. Okay. So what it says, force time delta t is equal to change in momentum, and change in momentum is equal to delta p. We know the value of delta p. Okay. What it says, and again one more thing, this force delta t, this is impulse, equals to, and this impulse from this graph is area, equals to delta p, right? So the area here will be equal to the change in momentum, which is 2mu. So let's calculate the area under the graph. So it's a simple triangle, so it's half base into height, half. So this is the base and this is the height, is nothing but 2 times of mu. From this statement we can calculate the value of F naught is equals to 4 mu divided by t. So it's quite easy. This is the answer of this situation. Let's move toward the numerical number 4. What numerical number 4 says? It says that we have a situation, again hydrostatic situation. So, something like this. Okay, and this is ground. A block is placed here having mass 2 kg. This is frictionless. Okay. Liquid jet is moving in this direction with velocity of 5 meter per second. This is the velocity of the liquid, and the mass is changing with time. So rate of change of mass, rate of flow of mass, you can say, is 1 kg per second. This is the rate of flow of liquid. Rate of flow of mass of liquid is dm upon dt, 1 kg per second, and the mass of the block is 2 kg. So the question is, when this jet hit the block start moving because force act on the block. So you need to calculate what is the acceleration of the block, what is the initial acceleration of the block. So calculate the acceleration of the block when this liquid jet hit the block. So let's move toward the acceleration. For acceleration we need to the value of force, then force divided by mass is nothing but acceleration. So acceleration can be written as force divided by mass. We know the value of mass is equal to 2 kg. So let's move it towards force. How we can calculate the value of force? So in such situation, when the mass is a variable quantity here, we can write velocity dm upon dt. So in this way we can write force. Usually we write force equals to mass into acceleration, or mass dv upon dt. So this dv upon dt is acceleration. we apply this situation when the velocity is variable but the mass is constant. But in this situation, the mass is variable and the velocity is constant. So here velocity is uniform. Velocity is uniform. That's why I am using this expression. So velocity comes out to be 5 and this is 1 divided by 2. Right? 5, 1 divided by mass equals to 2 kg. So 5 by 2 is nothing but 2.5 meter per second square. This is the answer of the numerical. So the calculation are quite easy, but the situation, if you are handling this situation first time, obviously you will face some difficulties how to start the numerical. That's why I am bringing different situations in this episode so that you become confident that you know very well how to handle the numericals based on impulse momentum theorem. I have one more numerical which is also based on liquid, or we can say hydrodynamics. So let's handle the hydrodynamic situation again. Here we will use the equation of continuity too, and if you don't know the equation of continuity, I will just briefly explain how to write the equation of continuity so that you can easily understand the numerical. So again I am saying, if you follow the DC Pandey, it's quite easy in reading and the examples are very good. So just follow one book and set up the time every day so that you can become familiar with the physics and you answer to yourself that yes, you know physics, how to solve the physics, and the fear of physics will not dominate you. So once the fear of physics dominates you, the 2 years will get wasted. You study physics every day, but if you are under the pressure of physics, you have a fear in your mind that you don't know how to solve the numericals, you don't pass with physics and all these silly questions, then obviously the result you know how you become in your life. So my advice, just simply follow very simple books, solve simple numerical, respect every numerical. Don't just look at the book page and say, oh, I can solve this. No, solve this. Respect every question. This is the statement given to me when I was in my 6th grade. I was solving mathematics and I have some difficulty in one of the numericals, and I go to my teacher named Rakesh Sharma, and he just says, you solve these questions? I said, yes, I solved first 8 questions and I don't know how to solve the 9th question. He just simply asked me, show me where you solve these questions. I said, it's easy. I know how to solve this. I know how to solve this. I know how to solve this. Then he replied to me, give respect to each question. At least if you know how to solve this, take 1 minute of your life, solve that question. Keep in mind, if you give respect to each and every question, you'll never face any difficulty while solving the numericals. So this is my advice to you in this lecture. So let's move toward our next numerical number 5. So here again the situation is something like this. This is a streamline motion, okay, and the area of cross section of these limbs are A. Liquid jet is moving with velocity v in this direction, and it's obviously coming in this direction. So we need to calculate how much force is the liquid is applying on these diagram, on these pipes, on these limbs. How much force we need to calculate. Okay, so it's streamline motion. One thing, the density of the liquid is rho. So density is rho, one thing, okay, and the area of cross section, all the limbs are equal, that is A. Now here we need to calculate the equation of continuity. What equation of continuity says, this is the input and these two are outputs. So input is, we can write a1 v1, and outputs we can write a2 v2 plus a3 v3. As these two limbs are identical and this angle is 60 degree, this angle again is 60 degree, so I write a v equals to a v dash plus a v dash. As the areas are same, areas are equal, so the velocity is moving, speed of liquid moving in these limbs will be equal. I am considering that speed v dash. So v dash is the variable here. A terms will cancel each other, so it comes out to be 2 times of v dash. So v dash is nothing but v by 2. So here we calculate the value of v dash. Now this liquid is also forcing to the system. This liquid, the flow of this liquid is also applying force on the limbs. So we have to add the contribution of this and this. So we have to calculate, we have to add the 3 force terms. The force applied by this, or rate of change of momentum. Rate of change of momentum by, so let's say it's limb 1, this is 2 and this is 3, by 1. We have solved this expression. I have already discussed how to write the rate of change of linear momentum due to a liquid flow from a pipe in my last video. So I will attach the link in the description box, so you can check how to write this and how to handle these angles. So I am writing here directly, it nothing but it will say rho a v square. So this is the force applied by this limb A. Okay, now the force or rate of change of momentum applied by limb 2 and 3. 2 and 3. So I am taking care of these two simultaneously. That's why I am writing 2. One from this side, one from this side. So 2 bracket. Follow this rho a v dash square. In place of v, we have here speed v dash square. But here again we have theta. So cos of 60 degree. So this is the expression, this is the contribution of the force applied by this limb and this limb. Okay, let's solve this. 2 times of rho a, v dash is nothing but v square by 4. When you square v dash, it comes v square by 4. Cos 60 is, which is equals to sin 30, 1 by 2. Again this 2 and this 2 cancel each other. Rho a v square by 4. So this is the contribution, combined contribution of these, and this is by the first limb. So add these two expressions. Let's say this is our expression number 1 and let's say this is our expression number 2. So the total force is nothing but rho a v square plus 1 by 4 rho a v square. When we solve this, it comes to be 5 by 4 rho a v square. This is the total force applied by the liquid on the system shown in the diagram. So this is our required answer. So this is all about in this lecture. I hope you enjoy this lecture, these variety of numericals from different situations. Wish you all the best. Stay continue with your physics and subscribe my channel, like the content, share with your friends. See you in the next video. Bye bye.